Good afternoon, everyone. So we'll be starting the session in another 5 minutes. So let everyone join. In the next 5 minutes, we'll start the session. So good afternoon, everyone. I hope everyone is here. So what did we discuss yesterday? What are all the things we have discussed yesterday? We have discussed about the pandas, right? And also we have implemented a NumPy notebook also, correct? And later on, what did we do? And also one more thing, I have shared the drive link yesterday with you, right? Were you people able to access the NumPy notebook? Everyone, Chetan, Vishal. Yesterday I have shared a drive link, right? Were you able to see the notebook over there? Okay, send again. Fine. I'll send that again, okay? Just give me a minute. Let me just check that once. Just a minute. Okay, Abhishek, you are able to. Okay, that's fine. Let me just share the drive link again once over here. And after that, I will immediately start, okay? Everyone, please go through the drive link. Under the notebook section, you'll be finding NumPy notebook. And for that, you'll be having all those. Just confirm me if you're able to see the link or not, okay? Just click on the link. You'll be able to see the notebooks. Open the notebooks. Under the notebooks, you'll find NumPy. And under the NumPy, you'll find the NumPy notebook, okay? Fine. So we have done that yesterday, and also we are done with Matplotlib and Seaborn, what exactly they are, and then we have dived into statistics. In the statistics, we have discussed about the types of data, correct? The types of data. So what are the different types of data we have discussed about? What are the different types of data we have discussed? Qualitative and quantitative, correct? What is qualitative and what is quantitative, guys? What is qualitative and what is quantitative? Is my voice clear and audible? Everyone, Abhishek, Ayush, Mega, Vishal. Okay. Yeah, fine. Thank you. Yeah, correct. Okay, qualitative is the categorical, Chetan. Okay? Categorical. And quantitative means numerical, correct. In the qualitative and quantitative, what are the different types we are having? Qualitative means nominal and ordinal. And quantitative is, under quantitative, what are we having? Discrete and continuous, correct. Discrete and continuous, we are having another quantitative. So, lag a lot. Okay, just a minute. Is it fine now? Is there any lag, Sumit? So we have discussed about qualitative, quantitative, and then we have started exploring the statistics part, but we didn't completely explore the statistics, correct? So now today we'll explore the statistics part, okay? And after that, we'll discuss the hypothesis testing, and then we'll move into the deep learning part. Then we'll start the actual Gen AI with the transformers, okay? In this week, we'll start the Gen AI with the transformers, and we'll also implement a text-to-text model, okay? Hope it's clear for everyone. I have just shared the link, Tejaswini. Okay, let me just share my screen. Just give me a minute. So everyone able to see the screen, right? I'm sharing my screen right now. Okay, fine. So we have discussed about these types of data, correct? So there was a topic called sampling and types of sampling, correct? Yesterday, when we are going through the slides, we got to see regarding this topic, sampling and types of sampling. So what exactly the sampling and what exactly the types of samplings are? Okay, now we will discuss about them. Later, we'll dive into the PPT ones. Okay. First, initially, I'll be explaining what exactly the sampling is, what exactly the sampling term is, and the types. Okay. But before understanding the sampling and the types, we need to know the difference between a sample and a population. Okay. Sample, population. Okay. We need to know the difference. Anyone know the difference between a sample and a population? Anyone? Anyone heard the difference between this sample and population? Anyone heard about population? No? Okay, fine. So, what is this sample? Population. Population means it's like the entire data, okay? Entire data which we're having. Or else the entire data set which we're having. Okay? Yes, correct. So population is the entire data or the whole data which we're having. And from that whole data, if you're considering only few values or else few observation or else only few rows, then we'll call it as a sample. Okay, then we'll call it as a sample. It's like considering a number of fixed observations. Okay, number of fixed observations or else say specific data, we can say specific data observations. So clear, the difference is nothing but when we consider, let's say in a data set, I'm having around 1 lakh values. Okay, 1 lakh rows I'm having and 5 columns I'm having. So if I'm considering each and every data point from that whole data set, then I will say it as a population. Okay, and if I'm considering only 10% of that values from the whole 1 lakh, then I will say I have considered a sample. Okay, It's like number of fixed observation or else a specific data. This is the main difference between a sample and population. And from this sample only we got this term, that is sampling. Sampling is nothing but considering a considering the fixed number of observations. Okay, fixed number of observations from the whole data of population. Okay, clear? Clear, guys? See, what is sampling? Sorry, what is first population? Population is considering the entire data. Okay, yeah, sample is a subset of population, correct? But what is sample again? If you are drawing a specific data, or if you are drawing only a specific number of observations from the whole data, from the entire data, then we'll call it as a sample. Number of fixed observation, we'll call it as a sample. What is sampling? Sampling is also the same. It's nothing but considering the subset of the population or considering the fixed number of observations from the whole data of the population. Okay, clear the difference between sampling, sample, and also this population? Sample and sampling are the same. Okay, you need to understand the difference between population and sample. Is the difference clear between them, everyone? Is it clear, guys, the difference? All the 65. Okay, got it. Thank you. Just give me a minute, just a moment. Okay, I'm sorry, I just got a call. Oh, okay, fine. So now we're done with the sampling and the population, right? So now we're gonna discuss about these types. Okay, what are the types present in this sampling? Anyone know what are the different types of sampling procedures which we are having? I'll just proceed with that. Okay. Simple random sampling. Okay, the first one is no sample. Okay, sampling. Amit, it's not slicing. Okay, sampling. Slicing is completely different when compared with sampling. I know why you said slicing, because they're considering only specific part, right? Maybe in that point of view, you have considered slicing, but it is called as sampling. Okay. So one is simple random sampling. The other one is systematic sampling. Okay, and there were mainly around 7 types actually, but we'll be considering only the 4. Okay, mainly 4 types we need to know about. simple random, systematic, stratified. Okay, stratified sampling, and then comes the clustered sampling. Okay, clustered sampling. So these are the types of the samplings. Okay, yeah, clustered sampling. I think you okay, fine. So what is this simple random sampling, Krishna? Krishnan, Krishan Kumar. Simple random sampling. The name itself is saying randomly we are drawing the samples, right? Random sampling is nothing but randomly we are drawing the samples. So we can say it as randomly samples are drawn from the entire population. Okay. Okay. Simple random sampling, what it is, randomly drawing the samples. Okay. Randomly drawing the samples. From where we'll be drawing the samples? From the population, right? From the entire population, we'll draw the samples. So considering the samples from the whole population is known as a simple random sampling technique. Is known as a simple random sampling technique. Then what is this systematic sampling? Systematic sampling is nothing but we'll be drawing the samples at regular intervals. Okay, at regular intervals. So systematic sampling is nothing but at regular intervals we'll be picking the samples. So how at regular intervals we'll be picking the samples? At every second, or else at every third point, every third data we'll be drawing, or else every 10th value we will consider, or else every 5th value we'll consider. Okay, so that is what the regular intervals is. Okay, so it's like when yesterday we were creating an array, right, with a range, and we are considering interval like 2 steps, correct? So that is nothing but a 2 steps interval, right? So in a similar pattern also we can do the systematic sampling. Okay, is that clear? Is that clear, guys? Up to here, simple random sampling and systematic sampling clear? Everyone? Any doubts on simple random and systematic? Not clear? Any doubts? Okay. Amit, any doubts? Fine. Okay, fine. So this is about the simple random sampling and a systematic sampling. So now we are left with this stratified and also clustered, right? So stratified and clustered will be almost similar, but there will be a slight difference. Here we'll have a subgroups, okay? We'll have the subgroups, then it will consider the samples from the subgroup, then consider the samples, okay, from subgroups actually. Fine. And clustered means it will be completely grouping them. Clustered means you all know, right? As you people are aware of this machine learning algorithms, right? So clustered means what happens? It will be dividing the things into groups, and from the groups it will be considering the samples. So in the stratified also it will be the same. It will create a subgroups, okay? It will create the subgroups and then consider the samples from the same, okay? Is that clear? These are the types of the sampling methods, okay? You just need to be aware of the sampling method. So stratified and clustered means directly we'll be dividing the things into groups, and from the group we'll be considering the samples, okay? Let's say the entire population is divided into 5 groups, and from the 5 groups we'll be considering only in each and every group we'll consider like one sample or else two samples, okay? That is the clustered format. And the stratified again it's the same, but here we'll divide the data into subgroups, okay? Here we'll divide the data based on the subgroups, then consider the samples. Okay, this is about the types of sampling: simple random sampling, systematic sampling, stratified sampling, clustered sampling. What is sampling? Considering the fixed number of observations from the whole data of the population. And what is sample? Number of fixed observations. Correct. Population is the entire data. Okay, this is about the samplings and types of sampling. I'll just share the PPT and I will just share the screen and we'll continue with the PPT. Okay, just give me a minute. It's clear for everyone, right? Regarding the samplings, sampling types of sampling. Anyone any doubts? Please let me know in the Q&A. Okay. Okay, this is about the types of sampling. Random sampling, stratified sampling, clustered sampling. Okay, and then comes the hypothesis testing. Okay, hypothesis testing. So in this hypothesis testing, we'll be having null hypothesis, alternate hypothesis, and what exactly the hypothesis testing is? It is a statistical test. Okay, it is a statistical test which is used to determine whether to reject or fail to reject the null hypothesis. That will be the statistical test. But what is this null hypothesis? What is this alternate hypothesis? And basically, what is hypothesis? Okay, so now we will be discussing about this hypothesis testing. Okay, now I want you people to let me know what is this hypothesis. What is hypothesis? What is hypothesis? Okay, to predict. Fine. I got one answer from one of our friend. They're saying that to predict. Okay. Any other answers from anyone? Yes, correct. So, Krishan, I think you are aware of all these concepts, right? Okay, assuming a result to be true or false, okay, Abhishek, hypothesis testing definition. We assume and do not have a solid evidence, okay. False, okay, okay, fine, totally fine, okay. Fine, I think you people are aware, so I'll just finish it off in 5 minutes, okay. So here we are discussing about this hypothesis testing, right? So in hypothesis testing, what are the main things? We have seen this null hypothesis, okay. Hypothesis is nothing but we will be testing whatever the assumptions which we are assuming, okay. What are the assumptions which we are assuming? We will be making sure that the assumption is being true or false, okay. We'll be considering two statements, the assumption statement or the assumed statement and the quite opposite contradictory statement, okay. We'll assume two statements and we'll try to prove which statement is true and which statement is false, okay. We'll consider both statements for the assumption which we are having. One statement will be like whatever the assumption which we are assuming is true, and the other statement will be completely contradictory, okay. So hypothesis means, let's say I have assumed a statement, okay. So let's consider an example for this. Okay, then the example is, let's say I'm working in a pharma domain and I have developed a drug, a medicine. Okay, and my assumption is the medicine is working good. Okay, the medicine is working good. So this is my hypothesis. Okay, this is my assumption. So what I just told, one hypothesis will be as per the assumption, saying that assumption is true, and the other hypothesis will be a contradictory statement. Correct. So this is the statement which I am passing. Okay, for a hypothesis, statement is the medicine is working good. Okay, now I told you, right, two statements will be passed. One is null. Okay, one is null, and the other is alternate. Okay, alternate. One is null hypothesis, and the other one is alternate hypothesis. What is this null hypothesis and alternate hypothesis? So, in null hypothesis, it is also denoted as H naught, or else we can say HO. And alternate hypothesis is denoted by HA. Okay, HA is nothing but H alternate. Okay. So, what is the statement for this hypothesis? The medicine is working good. And for the statement, for the assumption which we are doing, there will be two different assumptions, right? One is null and the other one is alternate, right? So in the null, what will be the statement? The statement will be the same as per the assumption, okay? Always the null will be the same as per the assumption, okay? Remember this, always the null will be the same as per the assumption. And the alternate will be the contradictory statement. The medicine is not working good, okay? This is the difference, okay, between the null and the alternate. And this is the statement which I am assuming. I need to prove either it is alternate hypothesis, correct, or we need to consider alternate hypothesis, or else the null hypothesis I need to prove. Okay, I need to prove this. So, understood until here? Everyone understood until here? Everyone understood until null and alternate, how we are assuming. So, by considering these two statements, we'll be doing the hypothesis testing. Okay, we'll do hypothesis testing. And to do hypothesis testing, there is a test called p-value test. Okay, p-value. By doing the p-value test only, we'll be considering which statement to consider. I mean, we'll be deciding which statement to consider and which statement to reject. Okay, just a minute. Okay, so what is this p-value? P-value is nothing but the probability value. Okay, prob value, we can say prob value. I'm sorry, there was a disturbance from my side. So we'll do a p-value test in order to decide which statement is correct. Okay, so that p-value test is nothing but the probability value test. Probability value. So we'll be having a threshold value. Okay, threshold as p-value p-value is 0.05. Okay, this is the threshold value. Okay, mostly this will be the threshold value, and based on the threshold value only we'll be considering to accept the null or reject the alternate. Okay, based on the p-value only we'll be deciding. So if our p-value, so if p-value is less than, if the p-value is less than 0.05, p-value is less than 0.05, right? Yeah, 0.05. Just a minute. Okay, we'll reject the null hypothesis. Okay, in this scenario we'll reject the null hypothesis. So as we are rejecting the null hypothesis, what are we doing? We are accepting the alternate hypothesis. Okay, as we are rejecting the null hypothesis in this scenario, we will be accepting the alternate hypothesis. Okay, as the p-value is less than 0.05, reject the null, accept the alternate. Okay, what if it, what if the p-value is greater than 0.05? The p-value greater than 0.05, it will be completely reversed, right? That's it. Okay, accept the null and reject the alternate. Correct. Understood. Understood regarding this hypothesis testing. There is this another testing called as A and B testing also. If anyone is from pharma related department, they can get to know this A and B testing. Now understood this hypothesis testing, the statement which you are considering, what is this null hypothesis, alternate hypothesis, how null is determined and how alternate is determined. What is this p-value test? P-value is a probability value test. What is the threshold value here? 0.05 is the threshold. And if the p-value is less than 0.05, then reject the null and accept the alternate hypothesis. And if the p-value is greater than 0.05, accept the null and reject the alternate hypothesis. Clear, everyone? Clear? Any doubts? Any other examples required? Let me know. Anyone, any doubts? Right? Okay. So I'll just add this point also. So yesterday we have seen measures of central tendency, right? It is very important. Okay. So measures, in coming into measures of central tendency, here we have mean, median and mode. Okay, these are very important when you are dealing with the null values in the machine learning data. Okay, fine. Remember this p-value less than 0.05, what to do, greater than 0.05, what to do. Okay, just go through these two things first. Just zoom out. Just go through this. Just go through this for 2 minutes. Okay, any doubts, let me know. So I hope everyone understood what is a null and what is an alternate, right? So null hypothesis statement about the population parameter assumed to be true, okay? Whatever the statement which is passed as per the data set. Okay, let's say we are having a data, and on that data, I got the output as the medicine is working good. So the same statement will be assumed for the null hypothesis, and for the alternate, a contradictory statement will be passed. I mean, a complete opposite statement will be considered, and a statistical test is done, whether to reject or accept the null hypothesis. And here we are having a other thing also. What is that? Not the Bayes theorem. Not even this type 1, type 2. Okay. Let's complete this Bayes theorem and we'll go to the topic. Okay. So just moving into Bayes theorem. So Bayes theorem is simple. We'll be having a statement, and we'll be considering these post probabilities and the peer probabilities. Then we'll be saying that that event is going to occur or not. Okay. So once go into this practical applications, what it is saying is widely used in medical diagnostics, spam filtering, and machine learning. It helps refine predictions based on observed data. Okay. It helps to refine the predictions based on the observed data, widely used in diagnostics, spam filtering, and machine learning. So what exactly is Bayes theorem? Anyone know the Bayes theorem? Bayes theorem is nothing but based on the probability of an event occurring. We'll be considering the previously happened events, previous observations, and based on the previous observations, we'll be predicting if that event is going to occur or not. Correct. Anyone know Bayes theorem? Anyone aware of Bayes theorem? Bayes theorem. Anyone? What is the Bayes theorem formula? It is P of A by B equals to P of B by A by, I mean P of B by A into P of A by PB, right? Yeah, probability of a particular event, and we'll be measuring the probability if that event will be occurring or not based on the prior and the post probabilities. Prior and the post. Prior is nothing but the previous observations, and we consider based on the previous observations, we'll be predicting if that event is going to happen or not. Correct. So coming into this application part, how we can consider on spam filtering based on the previous spam emails patterns, we'll be considering the current email as spam or not spam. Correct. So that is one kind of an application for the Bayes theorem concept. Okay. So this is about the pre and the post probabilities and the practical applications. Okay. I hope Bayes theorem concept is known to everyone. Okay. There is this central limit theorem also. This central limit theorem you people have learned during your time at 12, right? So the main thing of central limit theorem is nothing but when the sample size is greater than 30. Okay, when the sample, what are the sample which we are considering, if that size is greater than 30, okay, greater than 30 in the sense more than 30 observations, then it will say that the graph will be normally distributed. Okay, the sample and the population mean will be almost equivalent, and the plots will be normally distributed. So that is the main thing about this central limit theorem. The sample and the population mean will be almost the same, and the sample population, when it is greater than 30, then it will have a normal distribution, and it will be same as per the population distribution mean. Okay, these are the points to remember for central limit theorem. Remember central limit theorem? Okay, fine. Central limit theorem and the base theorem is done. So now, what is this type 1 and type 2 error? Type 1 and type 2 error. What are they saying type 1 and type 2 error means? So type 1 is rejecting the null hypothesis when it is actually true. So when whatever the statement which we are passing, it will be the null hypothesis, correct? So if that null hypothesis is actually true, but we are rejecting it, okay? But we are rejecting it. In that case, that is a type 1 error, okay? In that case, that is a type 1 error. So what is the example? A medical test incorrectly identifies a healthy person as having a disease. A person is actually not having any disease, okay? Is not having any disease. But as per the test, he is being identified as he is having a disease. So that is a type 1 error, okay? That is a type 1 error. So there is this type 2 error also. What is type 2 error? Failing to reject the null hypothesis when it is actually false, okay? What is the example again? A medical test fails to detect a disease in a person who actually has it. Understood the difference between type 1 and type 2? Everyone understood the difference between type 1 and type 2, base theorem, central limit theorem. Okay. So it's clear, right, until now, everyone? I have just created a poll. Let me know, okay? Up to type 1 and type 2 error, is it clear or not? Let me know. And if it is not clear, let me know what part is not clear, okay? Thank you. I'll just give 5 minutes. Just recollect the concept which we have discussed and let me know through the poll, okay? Okay, I hope it's clear. Now, I'll just give an overview of machine learning algorithms, and then we'll start with the deep learning concept, okay? And once that is done, we'll end the session for today, and from tomorrow, freshly, we'll start the transformers concept. Tomorrow's concept is very important, okay? I know you people are aware of this machine learning and deep learning, but understanding transformers is very important, okay? Once you understand the transformers concept, then you will know how actually a Gen AI is working, okay? Um, so let's have a break for 10 minutes, okay? Let's have a break for 10 minutes and we'll start the session again. Please take a break for 10 minutes. If you're having any doubts, let me know in the Q&A. Thank you. So I hope everyone is back from break. Okay, so now we'll discuss about this machine learning life cycle. Okay. What are the steps involved in the machine learning life cycle? Can anyone explain me? I mean, can anyone let me know? How many steps we have majorly? Anyone aware of this machine learning life cycle steps? Okay, fine. I'll just write the cycle steps. Based on that, you'll be understanding. And if you're getting bored, let me know, okay? So initially, the very first step in the life cycle is define the problem statement. We need to define the problem statement, okay? That is the very first step. So define the problem statement in the sense we need to understand what kind of domain the problem is related to, okay? Type of the data. Then comes the data gathering. Data gathering is nothing but collecting the data, okay? Collecting the data. Collecting what kind of data? The type of the problem that we're trying to solve related to that kind of data, okay? Data gathering. And then comes the data pre-processing, okay? Data pre-processing. Data pre-processing, then comes the model selection. Okay? After data pre-processing, what we'll be doing? We will select the model, okay? Model selection. What kind of model that we can go with, okay? Model selection. After the model selection, what we'll do, we'll split the things, okay? We'll split the data. Or else we can say splitting the data. Then comes the training. What training? Training the model. And then comes the evaluating the model. And then comes the test the model. Then finally, if there is any hyperparameter tuning required, if there is any hyperparameter tuning required, we'll do the hyperparameter tuning. So these are the machine learning lifecycle steps involved. Okay? So we'll be initially defining the problem statement, which kind of domain it is and the type of the data it is. Then we'll do the data gathering, or we can say data collection also. Collection, then comes the data pre-processing. In the data pre-processing, we'll be cleaning our data. Okay? We'll clean the data, we'll clear the null values, remove the duplicate values, all the data pre-processing, all those steps will be involved in this Data pre-processing. We can do the label encoding also. Hope you people know all those data pre-processing steps. Then we will go for the model selection. What kind of model to choose for? Depending upon the target column, we will be choosing the model. If it is a regression, we will be going for the regression models. If it is a classification, then we will be going for a classification models. And if it is completely not related to regression and classification, then we'll be going for unsupervised learning models. Okay. So based on that, we'll do the model selection. So then comes the splitting the data. We'll be split the data into 70-30 orals, 80-20, 75-25. So after splitting the data into X and Y, I mean into training and testing, then we'll train the model, evaluate the model using the evaluation metrics, then test the model on the test data. And if there is any hyperparameter tuning required, we'll do the hyperparameter tuning on the same data again. So these are the machine learning lifecycle steps. Okay. Clear everyone? Any explanation required in any of the steps? If anyone need any explanation in any one step, let me know. If not, I'll just proceed directly with the deep learning. Okay. And coming into algorithms, there are many algorithms. Okay. Algorithms. There is this linear regression, a regression problem. Logistic regression, uh, classification, and decision tree for both reg and classification. Okay. Reg in sense regression and classification. Decision tree, and also we are having a random forest. Okay. Random forest. We can use it both for decision tree and classification. I mean decision tree for regression and classification, random forest for regression and classification. And also we will have other algorithms which comes under this boosting. Okay. Under the boosting also we'll have few other algorithms. So there is this ensemble techniques. Ensemble techniques. Okay. Ensemble. It's not M. N. So these are some of the popular algorithms. Okay. When compared with regression and classification, these are some of the popular algorithms. And this is a machine learning life cycle. Everyone clear? Clear everyone? Just give me a confirmation, then I'll proceed with the deep learning algos. See, ensemble techniques is nothing but again the same, okay? Bagging and boosting. Bagging is nothing but again the random forest model, okay? Boosting is nothing but the add a boost model. Parallel and sequentially the operations will be happening. Sumit, Krishnan, Keep, Rohini, Chetan, clear everyone? All the 60 plus people clear? So if anyone is not aware of those machine learning steps, just go through the machine learning steps once. and make sure you're having a clarity. And in the next 5 minutes, we'll start this deep learning. Okay. So in the meantime, just go through those lines for the next 2 to 3 minutes. Okay. Okay, done everyone. Fine. So now we'll discuss about this deep learning. Okay, deep learning algorithms. In the meantime, What are the deep learning algorithms present? Yeah, I see someone raised their hand. Okay, they have cleared it. And let me just share the screen. Sharing my screen. Everyone able to see the screen, right? Types of machine learning algos. Types of machine learning. There is this supervised learning, unsupervised, and the reinforcement learning. Okay. Supervised is nothing but algorithm learning to map the inputs to the outputs by being trained on the label data set. So it's nothing but in the supervised learning, we'll be having the target variable, and in the supervised learning only, we'll have regression and classification. We'll have a labeled data. Okay, both the independent and dependent variables will be having. That is what the supervised learning is. On the available data only, we'll be training the data model. Okay, and unsupervised learning is nothing but here we'll be identifying the patterns. Okay, we'll not have a dependent column over here. All the columns will be independent of each other. So we'll try to discover the patterns and the relationships between the features. Okay, between the features of the data which we're having, and then we'll be dividing the things. Okay, dividing the things in the sense as per the relationships or the as per the patterns it is following, we'll be dividing the data into clusters or the groups in the unsupervised learning. And coming to reinforcement, this is important. Okay, reinforcement is nothing but it learns by taking actions in a environment and receiving the rewards or penalties to maximize the specific outcome. So here it works on a reward based system. Okay, works on a reward based system, and based on the task which is being performed by that particular model, either it will be rewarded or it will be punished. So the best example to consider for this reinforcement learning is when you people are using this chat GPT, you'll be seeing the responses, right? Response 1 and response 2, and there it will be asking you to select the type of a response that you're preferring, right? So if you're preferring response 1, then the response 1 will be rewarded and the response 2 will be penalized. Okay, and if you're preferring response 2, so response 2 will be rewarded and response 1 will be penalized. So in the next query, if you're asking, you'll be seeing the answer in the format of response 2. So that is one of the best examples for the reinforcement learning. Have you observed that? Did anyone observe the example which I just told for reinforcement learning? People use ChatGPT. Only one person observed it. Okay. So try to ask a query to ChatGPT whenever it is prompting to response 1 and response 2. So select any one of the preferred response and see, ask other queries and just check how it is responding. Okay. You'll be able to see a huge difference. Okay. You'll be able to see a huge difference. Okay, fine. So that is about a reinforcement learning. Okay. So the key difference is it requires the label training data, focuses on predicting the known outcomes. So here the outcomes are already known, okay, because we are having the label data, right? Both the independent and the dependent variables. And here we'll discover the hidden patterns on the unlabeled data and identify the relationships, okay? And reinforcement learns by the trial and error method. Then comes the key concepts and terminologies. What are the key concepts and terminologies? Algorithms, models, training data, testing data. So these are some of the key concepts and the terminologies which you'll get to hear most of the time when you're working on machine learning. Okay. So then comes the deep learning. Okay. What are the different models present in the deep learning? What are the different models present in the deep learning? Anyone? Can I get this answer from anyone? Okay, feed forward neural networks, convolutional neural network. Okay, okay, recurrent neural network. Okay, I think only one person knows about this deep learning algorithms. So we are having CNN, RNN. So initially we'll start with ANN, CNN, RNN, LSTM. Okay, these are the main algorithms. I'll just write over here. So what is deep learning? Deep learning is nothing but it will try to mimic the human brain. It will try to mimic the human brain, how the human brain is acting. So in a similar way, it will try to mimic the human brain. Okay. In this deep learning, we will work completely based on the neural networks. So deep learning will completely work based on neural networks and the layers. Okay. So in order to work with these neural networks and the layers, we'll be using TensorFlow and the Keras library. And what are the algorithms we are having? ANN, CNN, RNN, LSTM. ANN is artificial neural network, okay? And CNN is convolutional neural networks. How ANN works? In the ANN, we'll have a perceptron and we'll have an input data. And now based on the input data, the weights and the bias will be added and will be passed into the activation function. And based on that, we'll be getting an output. So that is how things work in ANN. So ANN is nothing but a feed forward neural network. Then coming into the CNN, how CNN works, we'll see. So what exactly is CNN? It is a convolutional neural network. Okay, convolutional neural network. So how the CNN is working? Deep learning on neural networks. How it is working? What is deep learning exactly? Subset of machine learning using neural networks with multiple layers. This I just now told. Right, an artificial neural network mimicking the human brain structure and the functions. And here also we'll have the layers input, hidden, and the output layer, which process the information. Output layer will be getting the information. These nodes are all the hidden layers, and these are all the inputs. And on the inputs, the weights and the bias will be added. Okay. And here both the feed forward neural networks happens and the backward propagation also happens in deep learning. Okay, backward propagation is nothing but if the predicted output is not equal to the actual output, then again the weights will be adjusted. Okay, the weights will be adjusted again. That will be sent as an input, and it will be predicting the output. Okay, we'll just see this. So that is what exactly happens in ANN. Okay, in ANN. Hope ANN everyone knows. Everyone aware of this ANN feed forward neural network and backward propagation? Everyone aware of it? I need response from everyone. Okay. Okay, I just got one response. Let me just keep a poll for this. Let me know in the poll. See, based upon the majority only, I'll be deciding to explain the things, or else I'll be just moving forward. Okay. Got only 15 votes as of now. Want everyone to do the voting. Okay. Okay. I see only 19 people voted for this. The majority of the people are saying they were aware of this feed forward and backward propagation. So I will not be explaining them. I'll be proceeding forward. Okay. If anyone wants the explanation for them in the last 10 minutes, let me know. Okay. So coming into CNN. So in the CNN architecture, the important layers of the components are the input image, the convolutional layers, the pooling layer, fully connected layers, and the output. Okay. So let's say I'm having an image of a car. Okay. On the image of a car, the filters will be applied. Okay. What filters? The 3 by 3, the 5 by 5, or the 7 by 7 filters will be applied on the image. And based upon the filter matrix, each and every block will be encoded, and then it will be saved. Okay. And then for the whole image, the filter will be applied. Okay. And for each and every pixel, the details will be saved. Okay. Saved in the sense the convolution layers will be happening. What they will do, they will extract the features using the filters. So what are the 3 by 3, 5 by 5, and 7 by 7 filters are there? They will extract the features, important features. Features are nothing but which help us to understand the image. Okay. They will extract the features, and then the pooling layer happens. Pooling layer means we'll reduce the dimensionality of the feature maps. What are the dimensionality we are getting by extracting the features? We'll reduce the dimensionality. How will reduce the dimensionality? There are two types of pooling layers: average pooling layer and the maximum pooling layer, max pooling layer. So average is nothing but whatever the matrix which we are having. From that we'll be considering the average of those values, and then we'll be doing the pooling. Max pooling is considering the maximum value from the matrix again. So these are the types of the pooling layers which are present. And then comes the fully connected layer. In the fully connected layer, we'll be having the flattened layer before that. Okay, before that we'll have the flattened layer, and in the fully connected layer we'll have the extracted features. Okay, and in between the operations happens to through activation function. Mostly we'll be using ReLU, and for the ReLU we'll be having the conditions like the, let's say the input is x to the ReLU activation function. Okay, if the text value is greater than 0, the output will be the x. Okay, and if the text is less than 0, the output will be 0. So this is the basic condition of ReLU. Okay, and mostly we'll be using ReLU as an activation function in CNN. So we are done until fully connected layers. So up to fully connected layers we are done, and then comes the output. Output is nothing but the final classification of the prediction. What are the final prediction of the classification which we are doing will be the final outcome of this CNN architecture. Clear, everyone? Need a detailed explanation about? Everyone clear, or else does anyone need a detailed explanation? Yeah, correct. Correct, Rohini. Regarding the feed forward and the backward. Okay. So I hope you people are aware of the CNN and RNN in that case. Okay, CNN only does. In the CNN, what happens? CNN are also called as traditional neural networks. Okay, they are also called as traditional neural networks. Why? We'll just see now. Okay, so RNN. Okay, in the deep learning, three main algorithms are CNN, RNN, LSTM. We are done with CNN. Now comes the RNN. RNN is recurrent neural networks. Okay, actually I have combined multiple slides. So RNN is recurrent neural networks. So recurrent neural networks are they're again a type of an artificial neural network where they process the data independently. Okay, traditional neural networks will process the data independently, but in recurrent neural networks, the order is important. Okay, in the recurrent neural networks, the order is important. What are the applications for it? Natural language, predicting the future events, time series, even generate the creative content. So the best example for this recurrent neural network is next word prediction. Okay, next word prediction is the best example for this recurrent neural network. So whenever you're trying to text your friend regarding a film or else regarding an outing, so let's say you're planning an outing with your friend to go to a film. Okay, so once you type let's go, so immediately you'll be seeing the predictions like out, tomorrow, film, correct? So as you're getting those predictions on your keyboard, right? Keyboard ribbon, right? So how you're getting those kind of predictions? It is happening through RNN algorithm only. Okay, it is happening through RNN algorithm only. Remember this. The best example of RNN is next word prediction, which we are able to see in our phone. Okay, so what exactly happens in RNN? It will consider each and every word as an input, and it will try to predict the next word. Okay, go through this. It's a comparison between a traditional neural networks and a recurrent neural network. Okay, just go through this. Clear? Understood the difference? In, in the traditional neural network, the order doesn't matter because each and every image will be different, so the order doesn't matter. Okay, and coming into RNN, the order does matter because it needs to predict the next word, right? It needs to predict the next sentence or the next word. Okay, so here the order of the information does matter. Okay, so this is a major difference between the traditional neural network and the recurrent neural network. But there is an issue with this recurrent neural network. Okay, they are having an issue called as vanishing gradient problem. In the recurrent neural network, we are having an issue, and that issue is known as vanishing gradient. Okay, so because of that vanishing gradient problem only, we got this LSTM algorithm into the picture. Anyone know what is this vanishing gradient? Anyone heard of this vanishing gradient? Okay, fine. So vanishing gradient is nothing but it will be resolving the long-term dependencies. Okay, it will try to resolve the long-term dependencies which RNN is facing. RNN was able to predict the next word only. Okay, RNN was able to predict the next word only, but it was unable to remember the long-term dependencies. In order to overcome that, LSTMs were brought into the picture, and that issue is known as a vanishing gradient problem. What is this gradient and what is vanishing gradient? What is this LSTM? We'll discuss tomorrow. Okay, as we're left with less than 10 minutes, so we'll just discuss about those vanishing gradient LSTMs tomorrow, and we'll start with the transformers architecture also. Clear, everyone? Is that clear? What would be the outcome after completing this training, Abhishek? Completely depends on you, right? In the training, we'll be going through all the transformers concept, GenAI related content, and we'll be implementing the notebooks also related to text, text to image. Correct. So it completely depends on you what you are learning from the training, right? This is related to GenAI and including the IBM Cloud. So you'll be learning about this IBM Cloud models, IBM Granite models, and how to implement those models. You'll be learning those things, okay? So you'll be getting to know how to implement the generative AI. So generative AI in the sense text to image, okay? Those kind of information you'll be getting to understand through this training course. Is that clear? Is that clear, Abhishek? Okay, timetable for these 2 weeks. Fine, I'll just share you the timetable. Okay, I'll share the timetable. But mostly from tomorrow, the main things will be starting. Okay, from the transformers are the main thing. Okay, from the transformers we'll be starting the session. So I'll share the timetable tomorrow only. Okay. Okay. In the meantime, anyone is having any doubts related to today's session, they may ask. Okay. If no one is having any doubts, you may leave the session. Thank you. Yes, the coding part is about to come. Okay. Also discuss about this GANs, VAs. Okay. Any doubts? You can ask me now. If no doubts, you may leave the session. Anyone, any doubts? Okay, if no one is having any doubt, you may leave the session. Okay, thanks for attending. The next 2 minutes, if I see no doubts, I'll just end the session. Okay. So whatever the concepts which you are getting to hear in these 2 days, okay, these are just the prerequisites. Actual notes you'll be receiving from transformers, okay, and the slides will not be shared. Is that clear? Okay, fine. So I see no one is having any other doubts. Thank you. So I'll be ending the session now. Thanks for attending.